The title of the presentation is Do we need a JHipster Kubernetes operator? And I would like to start asking by who is using Kubernetes today with JHipster or without JHipster, right? Okay, that's good. It's late already. It's 5:25 p.m. And that means that this might be a complicated conversation for this time of the day after a long day of presentations. But I wanted to use this opportunity here to just start the discussion about this topic, because I do believe that the answer to this question is yes. But in order to understand the full answer, we need to understand why we might need something like this. And in order to explain myself better, because again, it's a complex subject, it took me quite a while and quite a long journey by using Kubernetes in order to arrive to some of these things. So I want to save you guys some time, or at least use this to kickstart a more deeper conversation with the entire community. You can see that on the top of the slide, there is a GitHub repository where I just created a proof of concept of what the Kubernetes operator for JHipster should look like. But this is a very opinionated topic, and I will explain that during the presentation. And I will try to show some code and give you some pointers for you to try to run this in your clusters as well if you're interested in digging deeper. I'm more than happy to donate the code and to move the code somewhere else, or just to start another one from scratch, more based on and community feedback in general. So a little bit about me. I'm Mauricio Salatino, also known as Salaboy. I'm a Kubernetes addict in rehab. I'm currently unemployed because I took my addiction too seriously. And I spend too much time, creating clusters, deleting clusters, deploying services, removing services. I've been working with Kubernetes for the last 4 years. So it has been a long journey of learning and understanding what's going on in the Kubernetes space and in that community, which is quite different from the Java community itself. And because of that, I started contributing a little bit to Spring Cloud, and I started contributing to another project that it's called JenkinsX. And I'm a big JHipster supporter because I do believe that JHipster is solving a lot of problems that we will all have no matter what we are building. But at the same time, I realized that Kubernetes is quite different, and for Java developers, it's quite a big leap. So there is a lot of stuff that we need to build. There are a lot of tools that needs to be developed, and there is a big opportunity right now for us to have a wider discussion to discuss about what's the best way or what are the best tools that we should create. As we saw today in the keynote, I mean, that discussion about, okay, so do we create like a JHipster Kubernetes native approach, or do we use a Spring Cloud? Do we use both? Where is the line? And of course, the more options that you have, the more code that you need to maintain. So it's a quite interesting conversation, because we need to make some decisions at some point. Luckily for me, I have some friends teaching about Kubernetes, so I will be I will be partnering with this guy to teach a little bit about Kubernetes and my experience for the last 4 years. I will not be doing this full time, but I think that if you're interested in learning more about Kubernetes, get in touch with these guys. They are quite awesome. So main thing that I've learned during these last 4 years is that Kubernetes, again, it's a journey, and the journey of using Kubernetes and learning about Kubernetes is longer than anyone can thought about, right? Like when I begin using Kubernetes, it was all about, okay, let's get stuff running inside the cluster, right? And that's definitely the first step. When you want to go closer and closer and make sure that your applications uses the infrastructure in the best way possible, then you need to just start thinking about extending and automating and making sure that the infrastructure also understands about your domain-specific concerns. So it's a maturity kind of thing. You need to go through the steps, right? So if you are just starting with Kubernetes, I totally recommend you to keep pushing, try to get your stuff running in there, and then start thinking about what the next things are for you to make your applications better. So usually, when you start trying to run stuff on top of Kubernetes and you have a legacy application, you first of all just put that into a container. Then you'll try to understand the basics concepts inside Kubernetes, create some manifest or some YAML files so you can deploy that container into Kubernetes. And then you have your things running, right? But the moment that you have the things running, then you start thinking about, okay, is this application architecture to run in an efficient way inside Kubernetes? And most of the time, the answer is no. Luckily for us, we are using JHipster, and there are a lot of stuff here that it's already solved for us if we are using the microservice approach, right? If we are using the microservice approach, there are a lot of concepts, some coming from Spring Cloud, some coming from JHipster itself, that basically puts us a step forward, closer to what the cloud native patterns are, meaning that when we are running in Kubernetes, we are closer to a solution that looks more like Kubernetes native. So that's good. As was mentioned today in the keynote, the idea of using Spring Cloud, I usually see a Spring Cloud as a set of interfaces more than as a set of implementations. So in my ideal view of the world, we should use the Spring Cloud abstractions, but some of the implementations might change. Some of the implementations might need to rely on Kubernetes native services, or extensions, or Istio, or any other project that we think that it's the best tool for the job. But when we look at this architectural diagram, right, I was working on a project where we had the same problems, right? Like we ended up with a very similar diagram, because if you're using Spring Cloud, if you're building cloud-native Java applications, you will end up with something very, very similar. But because we were building tools for other people to create their own projects, we realized that something which is quite basic for the JHipster community is that we have something there in the middle here, right, like microservices and gateways, that it's very domain specific, right? That's where we are going to create our applications with our functionality. All the other stuff, we call it infrastructure. It's the things that are going to be shared by all the microservices and you can use, right? Then you start thinking about that. And a very, very, really nice concept that I love from JHipster is the concept of app JDL, right? That's encapsulating in a declarative way what's the business logic that you're trying to implement in there, what are the main services that you're going to have, and what are the types of the services that are going to be created by the generators, right? Also, you are defining the entities in there, so you can generate a lot of code and a lot of boilerplate that you don't want to code yourself, right? And based on the previous presentation, that was the case, and you can see that that's quite powerful. But again, the infrastructure will remain the same. So if we focus on the app JDL and all the code that it's generated in there, we are basically describing what the business is going to do with this application. And that's what I will be focusing on today with this presentation. So once you create an application, right, so you create an app JDL with some entities, with some services, with the gateway. The next step, if you want to run this in Kubernetes, you can use the Kubernetes generators, right? And there are 3 options nowadays, I would say. The first option is you just write the YAML files by hand, right? And for me, personally, that's a very good experience because you really learn about what Kubernetes needs in order to deploy containers and to orchestrate these containers. The second approach, when you write the YAML files by hand, you just do it once, you just do it twice. The third time, you just don't want to do it anymore. So definitely you can use a generator for that. And there are 2 generators nowadays. One that is called JHipster Kubernetes. It just generates the manifest files that you need to deploy your services. And the third one is the JHipster Kubernetes Helm, which uses Helm packages for bundling all the YAML files and to be able to release them as a package. I totally recommend the third option, mostly because Helm puts you closer to what you're going to be doing in real life, right? When you work with, when you work with JHipster, when you work with Java, you just create Java artifacts that you need to release for something like Nexus or Artifactory. When you work with containers, then you have Docker images that you need to release and tag. And when we work in Kubernetes, you might also need to package and release, Helm charts in this case. In the Kubernetes space, now you have the battle between Helm 2 and Helm 3 that it's just going out. And that's going to be another thing that we will need to take a look at. So, typical JHipster flow, you create an app JDL, you have services and you have gateways, and you know that you're going to be using a registry in order to do discovery. Usually you just run a generator, you generate the source code. That also generates Docker files. That means that now you have, you can create and tag and release Docker images. Finally, you run the JHipster Kubernetes generators and generate the Kubernetes manifest, right? With those manifests and by building and publishing the Docker images, you can deploy stuff into Kubernetes, right? And as soon as you deploy that into Kubernetes, then you are in the first step. You can just run stuff. Yeah. Now you can run stuff that it's more cloud native than a monolith in a Docker container. Yes, that's good. But at the end of the day, you just run stuff in the broad sense of the term, right? When you go in Kubernetes and look what's in there, you will see pods, deployments, and services, which are basically basic Kubernetes native concepts, right? You're not going to see anything about JHipster in there. You're not going to see anything related to the app itself, besides some labels that we can put into these concepts in order to group them together. But when you're running stuff like that, and when you keep running and when you keep working on real-life project, you will want to have some lifecycle management on top of these apps. And you might start wondering of, okay, so I have one app, fine. I have 2 apps, I have 3 apps, they are all different. They need to scale in different ways. So how can we achieve that? How can we teach Kubernetes about JHipster apps in general? Quick note, I've been working for the last 2 years in remote clusters. For me, that gives you like the real experience of working in a production environment all the time. So you reduce the gap between what's production and what's development by using real clusters. For me, that's a great experience, and I think that there is a, for developers, you need to take a huge leap into working in that way. And there are tons of tools that are going out to allow you to do that, right? If you want to work locally, you can use something like Minikube or Kind. I've just posted a blog post today about running a JHipster application using Kind. And Kind gives you a couple of cool things, right? The first thing is that it only depends on Docker. So basically, you can create the Kubernetes cluster with a set of Docker images. And that will boot up an entire cluster that can be multi-node. So you can have multiple nodes, like simulating multiple machines with Docker images running. That's quite cool, but it's the coolest thing that Kind has is that you can create and delete clusters, and those clusters are hermetic, right? The main purpose of Kind is to enable you to create integration testing and conformance testing, right? Where you can choose the right version of Kubernetes, where you can just test your applications in there. Again, trying to reduce that difference between development and production clusters, right? So you want to make sure that you test as much as you can in the same way that the code is going to run in a production place. So you will see a lot of these like test containers that was mentioned before for making sure that whatever you're running, it's running as it should run in a more realistic environment. And Kind is doing a very good job at that. Now, when you are running stuff, right? So let's say that you're running this application in Kubernetes, right? And that's fine, that's working okay. But again, questions will arise. How do we handle multiple applications? How do we make sure that Kubernetes understands how to scale a JHipster app? How do we teach Kubernetes to understand about when the app is up and running and healthy, right? You can say, okay, well, we can look at the services of the app, but there is nothing looking at the app as a whole, right? There is no concept that explains that takes care of that, right? In this left side of the picture, we have something that is quite clear. This is an app. It has all these modules. It has all these services. In the other side, we just have a bunch of Kubernetes stuff running. And again, we can use some techniques in order to group those things, but that's not lifecycle management. We're just running something in there, and then we leave it to the operators, to the people that it's looking into these environments to take care of that. And that's, for me, that's not good enough. And that's why we need to start thinking about, okay, so how do we extend Kubernetes to understand JHipster specific concepts, right? Because there are a lot of specific things there in JHipster that we can teach Kubernetes about, right? So in order to do that, we look at our domain-specific things that we have, and then we just define these as concepts and resources, right? And Kubernetes provides a couple of extension points that are very helpful in order to do that. And those are called custom resource definitions, or CRDs, which are basically a way to create new concepts, new resources for Kubernetes to use, and extend the Kubernetes API to understand about these new things. Finally, when we define our custom resource definitions, then we need to write a component that understands our domain-specific concepts and link those concepts against the Kubernetes concepts. If we talk about extending Kubernetes, most of the projects associated to Kubernetes that you might hear, like Istio, Knative, or JenkinsX, are basically mere extensions of the Kubernetes APIs and the Kubernetes concepts, right? Istio is a service mesh. How many of you guys know Istio? Yeah, that's quite popular. This is just an extension, right? They created their own service mesh concepts, and they're creating some components that understand these concepts and extend Kubernetes with these, behaviors. Knative functions as a service, serverless kind of like approach, same idea. They just created some concepts, and they can teach kind of like Kubernetes how to react with this idea of functions. And JenkinsX the same about CI/CD. So they have some concepts which are becoming kind of like a standard. They are called Tecton pipelines, and again, you have a concept that is called pipeline, and then Kubernetes will understand how to run these pipelines in a cloud-native approach. That's quite cool. And in these examples, right, like the second one, Knative, is using Istio, and the third one is using Istio and Knative, right? You can see how, by building concepts, then you can integrate and aggregate, behaviors together. So that's quite cool. So that's why when you start thinking about these things and looking at what other projects are doing, then you will arrive to the concept of operator, right? In order to understand what an operator is, we need to know what the controller is in the world of Kubernetes. And a controller is basically something that it's actively monitoring and maintaining a set of Kubernetes resources in the desired state, right? So if you think about the internal Kubernetes services that are looking at the state of the cluster, and they receive some YAML files with the desired state, and they actuate, like basically they operate on top of those definitions to change the state of the cluster. And an operator is a more complex controller that basically takes into consideration some domain-specific or custom resource definitions that basically encapsulate this operational knowledge about how to deal with the JHipster specific behavior, right? In general, operators will control and monitor the state of the cluster. They will wait for some kind of like user-defined and declarative state or resources or definitions, and basically they will go into this reconcile loop, which basically will try to match the desired state to the current state of the cluster, and it will keep looping and looking for changes until the state of the cluster is the one that it's desired, right? And again, as I mentioned before, it's the perfect place to create integrations with other behaviors, right? So if we think about, okay, how JHipster overlaps with, with Istio, for example, with the service mesh, right? Okay, well, maybe we need an operator to create this integration and to say, okay, these are like JHipster things that are important. These are the JHipster concepts. These are the service mesh concepts. Okay, so how do we relate to each other? And what's the expected behavior for a JHipster user? So that's why I thought that, okay, it will be really good to create like an initial version of a JHipster operator, and I take a stab at it in the last 2 weeks. I've been creating some other operators and some of the demos around this, so it was quite easy for me to migrate another example to say, okay, now I know a little bit more about JHipster, so I can create something to at least try to explain what the idea behind is. In general, when you have an operator, you have something that is called root resource, right? It's the main concept that this operator will take care of. So for the JHipster operator that I've created 4 concepts which are quite natural to me. So we have gateway, right? That's a service type. Microservices, which are any microservice that you can create with the generator. And then I created registry. But on top of that, I created the JHipster application, which is the concept that bundles, like glue all the things together, right? So a gateway, a set of microservices, and a registry might belong to an application, so the operator knows how to wire them up together and how to look at them as a whole instead of as separated services that are running. So I created those concepts, and the next step is that I wanted to make sure that Kubernetes is now aware of these concepts. So I created a component that is called the JHipster operator that will look at these resources and then match that with the Kubernetes native concepts, like services or deployments. This operator is in charge of understanding, again, the whole application state. So in order to say that an application is healthy, we need to have all the services that are defined in the app.jdl up and running, for example. And we can automate that process, right? So we can see, sometimes in the Hello World demo, when you deploy a set of services, all of them, they are going to green, they are all going to start, right? But in real life, sometimes Kubernetes runs out of memory or your node runs out of memory, so a service is not scheduled for some time, right? At that point, your application is kind of like half working, right? It's not working completely. And that's, of course, that's kind of like one of the characteristics of these distributed applications. So you need to build resiliency into the applications as itself. But now you have a point that you can go and extend and say, well, this is my specific JHipster application. For this application to be healthy, 60% of the service needs to be up, or these key services needs to be up, right? You have that level of flexibility. Because now we understand about the structure of the application, we can also provide some like hierarchical routing. If you think about multiple applications like here in the diagram, the operator will know now that application A has gateway and 3 microservices and the registry, something like that. So it will know that in order to route request to that application, it needs to go through that hierarchy, right? It knows that that service belongs to app A. That means that you can create some kind of router that allow you to reference that application in that context. And then we can, of course, start looking into more advanced topics like versioning, right? What happens with application versions, right? Do we want to have multiple versions of the same application? Do we want to have only different versions of the services inside the application? How do we deal with that? How do we do upgrades? How do we do rolling upgrades of an entire application? That becomes more advanced, and it's topic for further discussion. So let's see, as usual, when you work with Kubernetes, you see code and you see a lot of YAML stuff. It's not just pure code. Let me try to show a couple of things here. So let's go here. So again, that's in GitHub already. This is my application JDL. Let me put this here. Let's see if it works. Yep. So is that okay? Yep. So this is the application JDL file. And again, as I mentioned before, I have a gateway, I have an invoice service, and I have a review service. I just copied this from somewhere. And I just generated this application. I didn't want to spend time looking too much into this. It has a couple of entities. It's all good there. Like you just run the generators, import JDL as David did, and you get the app up and running there. After doing that, of course I build the Docker images for all the services, right? And then I run the JHipster Kubernetes generator, not the Helm one, just the Kubernetes generator. And then I just deployed all the services in a cluster using kind, right? So I have already a Kubernetes cluster here, and we can see that all the pods are running for that application, and that application is running there. You can see that there is a gateway, and there is an invoice service, there is the registry, and a review service, plus all the MySQL databases that are required for those services to run. So if we go here to Chrome, right, like that application is up and running there. Nothing fancy there. I didn't want to spend much time on that. If you haven't tried the Kubernetes generators, give it a try. Again, this blog post is all about that and about how do you get that application up and running into a kind cluster. And kind, again, is just a Kubernetes cluster, so it feels really natural for people that it's used to work with Kubernetes. If you haven't done it, I totally recommend you that, because it will give you, some real experience about how to work with these infrastructures. That's the source code, and the source code. And usually, when I create a presentation, I usually try to create a way for you to reproduce the same things that I'm running here. And again, the GitHub repository has kind of like the getting started guide on how to deploy this and how to run it, so you can test it. I totally recommend you doing that if you're interested in this topic. It's very, you will learn stuff if you try to run this. And in order to run this, you need the previous blog post, which get the application up and running. So if we take a look a little bit at the code of the application, it's just a Spring Boot application. It's nothing weird there. It's just a Spring Boot application that it's going to use a Spring Cloud Kubernetes only in order to get the APIs in order to interact with the Kubernetes cluster, right? So you can imagine that we have a component that is running inside Kubernetes, and it needs to interact with the cluster. And in order to interact with the cluster, that's done just calling REST APIs. And of course, we are in the Java world here, so I would like to have a library to do that. I don't want to just handcraft all the HTTP REST calls or post calls there. So I'm just using that library, which is Spring Cloud Kubernetes, that brings something called the Kubernetes client library in order to do these calls. Something important to mention here, this is a very basic Spring Boot app, but if you start looking into Kubernetes operator, you will see that the Kubernetes community usually build operators with Go, right? That's kind of like the native language of the Kubernetes community, but there is nothing for you to stop you to write like your own operators in Java. And I've seen some other projects already starting to build their own Kubernetes operators on Java. So there is nothing technically wrong of building your operator in Java, and these kind of projects demonstrate that you can do it, and it's not more than a Spring Boot application. So the Spring Boot application, it has just a scheduling, scheduler there, a Spring Boot application. It has a basic loop that it's called reconcile loop that basically checks if the operator has bootstrapped already or not. And if it's bootstrapped already, meaning that all the initialization code already happened, we will just reconcile, right? And remember that reconcile means to get the desired state, notify the cluster that there is a new desired state, and let the cluster work in order to get to that desired state, right? There is just one main class here that is called operator that is in charge of running this reconcile loop. And again, we have an in-memory place where we just put the desired state, and then we iterate over that in-memory state, and then you just apply that into the cluster by doing some calls like this one, right? Which is basically going to change the state of the cluster. It's going to change the desired state, and the cluster will just react on top of that. But in order to do all of that, in order to create this component, the first thing, as I mentioned before, is we need to define our own concepts, right? It would be great to say, Kubernetes, tell me about the JHipster applications that are deployed in this cluster. Very specific. Tell me about the JHipster applications. And that can be done. So let me go to the terminal. And again, because I have the application up and running here, the only thing that I want to do now is I want to deploy this JHipster operator, right? So I will go to the Kubernetes folder, bash deploy. And this is, again, this is just going to apply a bunch of YAML files into the Kubernetes cluster. And I wanted to analyze a little bit about the output, right? So these bottom 4 lines are my custom resource definitions for these new types, right? So we have applications, we have gateways, we have microservices, and we have registries. So we will use these concepts in order to define applications, right? An application will be composed by these blocks, microservices and gateways and registries, right? So that's the first thing that we need to understand. This means that when I deploy the service, I also deploy these definitions, which are YAML files. We can take a look at, for example, the application custom resource definition. And again, this is just a YAML saying, okay, this is a new definition of a custom resource definition type. It has a specific thing, a specific kind application. The short name for these applications are JH, and we will see how can we use that a little later on. And there is a group which is the JHipster group, right? So again, it's like an artifact for Kubernetes. But as soon as I deploy this into Kubernetes, what I can do is I can do something like this. So in the same way that I can do Kubernetes kubectl get pods, which is a native concept, we can see that the operator is starting. I can also do now kh get JHipster applications, right? And the first time it will fail, the second time it will tell me, okay, there is no JHipster application up and running, right? The main reason why it's nothing running just yet is that the operator is not aware that we have deployed a JHipster application. And basically the operator is built in a way that I need to notify what the application structure is to the operator, so the operator can go and monitor the cluster for the application to see if it's running or not, right? That means that the cluster now is also aware about microservices, so no microservices there, and no registries, right? When I deploy the JHipster operator, by deploying these custom resource definitions, we extended the Kubernetes API to understand about these concepts. Now you can do this with kubectl, or you can call the REST endpoints to get the information about these things. But again, we just deploy the definitions, not the instances of these resources, right? So now we need to create the instances of these resources so the cluster is aware of these new things. And the operator itself, it's going to monitor these things, right? So if we go to the operator, besides the reconcile loop, you will see that there are a lot of watches, right? So we want to watch new resources, new gateway resources. We need to watch new registry resources. We need to watch new microservices resources. So every time that a new microservice, registry, or gateway, or an application is created, the operator will be notified, and it will wire things together, right? So in order to do that, I created just a controller that basically has a post endpoint called apps, where I can just send an app JDL, which contains the structure of my application. It will just read the app JDL. It will parse that app JDL, which took us some time because there is no Java parser for it. And I think that we need to create one, or at least the grammar. And as soon as we parse that, we can just create a Java structure for that app JDL, and then we can just notify the cluster about these new resources, right? In order to do that, basically I created a JSON file, which is, this is my new application kind of like request, which basically contains a name, a version, and the content of the JDL file that I used to generate this application. So now I can notify, sorry if you guys cannot see that, it's pretty simple, right? The main reason why I did this, and we can discuss that this is basically why we need a discussion about these topics, is that the app JDL file, it doesn't contain the app name or the version of the app, right? It just contains the names of the modules. So as soon as unless I'm missing something big there, but that's why I just created this JSON, so I can just send this content to the server, right? So in order to do that, again, because I'm running in a Kubernetes cluster, I have a service for that Kubernetes operator, right? So I have a service that it's called JHipster operator, but I cannot access this service from outside the cluster. So in order to access that service from outside the cluster, I need to do a port forwarding here. So now I can access under the 8081 port. That means that if I do localhost, HTTP localhost 8081, right, apps. No, that's not going to work. apps, right? So I get an empty array there. I don't know if you can see that. Let me do that again. So you get that empty array. There is no apps. There are no apps defined. Basically, that means the same of doing that, right? I have no apps defined. Now, if I want to send a new app JDL definition to the server, I can do post localhost 8081 with the JSON that we saw before, right? Request JSON. It's not here. Okay. Here. Post localhost 8081 apps request JSON. Let me do this correctly. All right. That usually works. Let me see why not. But request. Ooh. Can somebody spot the error there? Okay. That might mean something different. So we can do logs -f to see that the operator started. It seems that it started, right? It is starting. It's very difficult to see with the lower resolution here, but basically it's showing up the reconcile loop that it's running all over again every 10 seconds, I think. And again, it's very difficult to see here. I will definitely create a blog post with the right output here, but it's basically saying that the operator is starting, it's looking at the custom resource definition to see that they are deployed. If they are deployed, then it can start working, and it registers all the watches for that. And now we need to figure out why this HTTP post is not working. Localhost 8081/apps. That's 400, that request. Okay, let me see. Apps. Interesting. That used to work. All right. So demo gods are not on my side today. I tested before, but now it's not working. In any case, as soon as I send the app JDL, this is going to parse that, and it's going to create the new resources as we create the resources manually with YAML, right? So you can, of course, go and create the resources manually with YAML and notify the cluster about this new application and the structure of this application. I have.
Is there a request JSON for it?
That's very good. Yep. So, okay. So we can cut the request JSON here. And I could assume that it is, but you might be right. So what we can do is I can see if I don't have any changes on this, right? So let me see here. There are no changes whatsoever, but there seems to be like the JSON broken, right? Yeah, you're kind of right. Like that thing is definitely wrong. But it should show me something here on the... sorry?
Remove the comma in the end of this line.
Yeah, but then it needs to be kind of like, okay, yeah. Yeah, that's it. That's probably it, right?
And then try again.
Yeah, that's a valid JSON. So it needs to be valid JSON. That's pretty basic stuff.
Yeah,
Slash. That's it. Thank you, guys. Yeah, that's pretty much it. So now, again, if you see here in the output, basically what it's saying is that, okay, all the watches are starting because new resources were created, right? So we parsed the app JDL. We said, okay, this application has 2 microservices. The services are registered. Sorry about the output. Then a bunch of stuff happens in order to try to figure out what's the external URL for this application. And you will see again when this loop kicks again, hopefully it's clearer. At the end, we have one message here that says, okay, this app that is called first JHipster app, it has a status healthy because all the services are up and running. And we have a public URL here for the application, right? And here we can talk a little bit about more about that, like hierarchical routing in this case. And we can do that kind of things like saying apps / the name of the app, version 1.0, and after that we can access to the application, for example, gateway, right? If we access to go app / version / services, we can access to the services inside the app, right? So we can do all these kind of things, but the most important thing for me, at least, is that we can definitely do this Kubernetes get JHipster applications. Now we have an application up and running there. We can see the status that it's healthy. That means that all the services are up and running. And the moment that I kill one of the services, that the status will change, and we might remove that application, from public usage, right? Depending on our rules for what an application is and how the application should work. So This is kind of like a lot, I know, for this time of the day, but I totally recommend you guys to take a look at the source code of the application and the source code of the operator, and give it a try. And I guess that I really hope that we can start working together into say, okay, we need this kind of stuff if you're running into Kubernetes. How is the Kubernetes roadmap is going to look moving forward? Right now, again, we are just running the application inside Kubernetes. I want to see more. I want to see advanced lifecycle management. I want to see, this kind of like hierarchical routing. I think it's important. I want to see integration with Istio and, more domain-specific routing for our applications inside JHipster. And of course, that idea of having multiple applications, it's something that I would assume that people will want, right? Like you just build the first one. You don't want to keep making that application grow and grow, and you probably have different teams working on different applications. So it makes a lot of sense to, to add all these capabilities. And it feels wrong to add that into a component that doesn't understand about the infrastructure. We need to definitely merge these two worlds, because at the end of the day, the infrastructure will know on how to scale our applications. And that's kind of like the key takeaway here. Again, one more thing that I can mention about this, Kubernetes operator is that because I kind of like it, I really like the Spring Cloud Gateway project. That's why I'm providing hierarchical routing there, because I have a gateway embedded in it. I wanted to play around with it, and basically I'm registering new routes to route traffic against through the operator based on this, this hierarchical structure of the application. So I couldn't make it work because I didn't have enough time, but I'm pretty sure that the community will know how to solve these problems, right? So if I go here to this URL, let's see. So before that, we can do, let me see here, localhost 8081, actuator gateway routes. That's because I have the Spring Cloud Gateway, right? It says nothing, so I need to probably post 8081 to refresh the routes. And let's see if that makes the routes to appear. Yeah, so based on the application definition, again, by looking at the Kubernetes resources that we have, we can definitely create these hierarchical routes here. So I'm creating services, and then I have invoice inside, and I have review inside. I have another route for the gateway, and I have another route for the registry if I want to go straight and add the registry. And this, of course, when you're doing this exercise, you start asking questions about, okay, is the registry infrastructure something that all the JHipster applications will share? Do we want isolation? Do we want to make sure that when we deploy a new JHipster application, there is a registry already running? How do we want to deal with all these things? And again, that's not something that I have all the answers for. That's why we definitely need a conversation about that. And again, as I mentioned before, I couldn't get this running because basically this Kubernetes operator now is acting as a gateway of gateways. So in order to get that working, we will definitely need more work. So for example, if you try to access this again, you will see that it's trying to go to the gateway, right? It is definitely going there to the gateway, but it's failing because the context path of the application, of the gateway application. But this is definitely doable, right? It's just configuring and wiring up things together in the right way. The same with the services, right? Services. So now the routes and the operator knows that there are services, an invoice, for example. So you can see that as well there, right? Like, and it's running. So again, I think that this gives a huge plus. Also gives the opportunity of creating some kind of like administrator, like UI or front end for dealing with JHipster applications while they are running. So again, it's a great place for integrations and and adding more management and lifecycle management capabilities on top of what we can run already in Kubernetes. So I do believe that this is a very interesting thing if you're into Kubernetes. Let me try to say a couple of other things about this. Again, feel free to get in touch about the code. We can definitely move it and we can work together on the next iteration. You will see that nowadays in the industry, in the Kubernetes community, they of course are starting to talk more and more about this, about the maturity model for operators themselves, right? And again, if you're using Helm, you are kind of like at the basic step of, okay, we can install this package that basically will deploy a set of containers, create a set of concepts, but what else can we do on top of that? So you have lifecycle management, upgrades, making sure that we understand what our applications look like and how they need to be scaled, how they need to be monitored, and then deep insights like looking at our applications' behaviors and fine-tuning based on that, and then autopilot at the end, which is basically our applications can take care of themselves, basically. And that's quite like, no, I don't think that anybody is doing that right now, but that's the direction where we should go. And again, quite a complicated subject, but I really enjoy doing this, and I'm really passionate about the hipster community because, again, it's solving a bunch of problems that, as developers, we don't want to solve. We need to solve it as a community. We need to contribute there and just try to get as much of these things as possible. For the future, and again, this is kind of like the ideal world, let's say 2 years ahead, is try to get all these things working together nicely, right? It's not cloud related, it's not related to any cloud provider. That might be considered another set of extensions. But I'm really passionate about CI/CD. I would love to see that JHipster and JHipster applications on Kubernetes, we have like a continuous delivery approach, where we just change stuff in repositories and we use GitOps to say, okay, we have the infrastructure running in a Git repository, we have a cluster replicating that infrastructure. Whatever we change, we just create a new release and we just have that running in an environment. That's quite a powerful message. If you haven't looked at JenkinsX or what's the other, Spinnaker, you definitely need to take a look at these projects. And of course, Knative and Istio are things that are widely used now in the Kubernetes community, and there are tons of projects like leveraging this because, again, as in JHipster, we don't want to reinvent the things that are already out there. So when you're in the Kubernetes space, there are a lot of things happening, so you need to keep an eye on that. I will keep my presentation short. I think that I'm almost out of time. But if you have questions now, I will be working with people that answer questions. So feel free to get in touch. And again, I really ask you guys to get involved with this. If you want to share comments, I created a list of to-dos for the project, but I will be more than happy to throw away the code and start a new thing if it's more like community-driven, right? But feel free to play around with that. And thank you very much for listening and staying till this late.